Okay, let's talk about how we want to do this project that y'all are going to work on. Now, let's talk about the steps for how we would do this, and then that way, this will help you not only to prepare for the quiz, but it will also help you in working on your project. So, what we want to start off with is our graph. Okay, now we know that we're going to be looking at a graph where we're going to start at x cubed. Now, of course, what we should notice is that that would end up looking like this. Okay, so we know that we're going to have a curve like so. Now it turns out that that we also want to know the line tangent to y at 1, 1. Okay, so here's 1, 1. Now, by the way, if it's tangent, now none of y'all have one quite as tricky as this one, but let's just go through the steps. If it's tangent, then we need to know the slope. Well, the slope is 3x squared, and the slope at x equals 1 would be 3. So we already know that. We know that the equation is y minus 1 equals the slope times x minus 1. So therefore, the equation should be y equals 3x minus 2. Now that's going to be our equation. Okay, so if we're looking at that, we know that's going to come through here. Okay, and we know it's going to come through here as well, and eventually it's going to end up crossing that line that we had. Okay, so they're going to cross at this point here. Now, so what we've got is we know that we're going to see where they cross, and there are two different places. So the places where they cross, that's going to be where 3x minus 2 is equal to x cubed. Okay, so if we go ahead and we put that onto one side, okay, then we know that's going to end up being 0 equals x cubed minus 3x plus 2. Now, big question would be, well, we know one of the places is going to be x equals 1. We already know that because we saw that that was where it touched it in the first place. But what about the second one, where we're looking for something around negative 2? Well, it turns out if we plugged in negative 2, well, it turns out that's actually correct. So it's actually 1 or negative 2. Now remember what we said before is when you just wanted to check really quickly to see if your answer was fairly obvious, you can plug those in. You can plug in numbers between negative 3 and 3. So in this case, negative 2 happens to be correct. So those would have worked. If that hadn't worked, you notice that you cannot use quadratic formula because it's not quadratic. It's x cubed. And that's why we also can't factor. So if some of you tried to factor, well, that's not going to work. So we know that our integral is going to be from negative 2 to 1. Now what we're saying though is that we're going to find a 3D volume, okay? Now what I want y'all to notice is that we're not going to look at the area. See, the sheet that we got this one from, the sheet that we got it from is trying to find this area in here. Okay, it's trying to find this whole area there. That's what they're trying to do. So in a case like that, what you would have done is you would have said, well, negative 2 to 1, and you would have said, let's take the top equation, which is x cubed, and let's subtract the bottom part, which is 3x minus 2, we say dx, which is the same as negative 2 to 1 of x cubed minus 3x plus 2 dx. So then when you would have integrated, you would have gotten x to the 4th over 4 minus 3x squared over 2 plus 2x from negative 2 to 1. And then you would have plugged that in, and you would have gotten, for the first part, that would have been 1/4 minus 3 halves plus 2, then minus the quantity of 16 over 4 minus 12 over 2, then minus 4. Okay, so you would have then ended up with, let's see here, that would be, let's combine these. You'd have negative 15 fourths plus 9 halves plus 6. And so that's going to end up being, let's see here, that's 9 fourths, so 18 fourths, so 3 fourths. So 6 and 3 fourths or that would have been 27/4. Okay, now that's how much that would have been. Okay, if we were just finding the area, but that's not what we're looking for. What we're looking for is we want a series of semicircles that are going to come off of the page. So in other words, each one of them is like another little semicircle coming off the page over and over until finally they end up coming to a close. Okay? So all these semicircles, okay, and it's a nice little 3D shape. Anyway, so the point being is that with each one of them, they're going to come up off the page, but the base is going to be the base of the semicircle. So what we're going to say is that the area of each semicircle, notice that's 1/2 of pi r squared. Now, another way of looking at this, though, is that the radius is half of this. So we want the radius to be half of whatever the difference is from the top equation minus the bottom equation. Okay? That's squared. So whatever it is that the top equation is, f of x, subtract the g of x on the bottom, and then create half of it as your radius. So what we're saying is that every one of those semicircles has an area. And what we're going to do is we're going to integrate all of those from -2 to 1, all the areas, over the course of dx. So let's see how we would do that. Now notice we had 1/2, okay. Now in our f of x, that was x cubed because that's on top, and it's minus, we had 3x minus 2. Let's see, that's going to be all that in there, squared. Now let's pull out the 1/2s, okay? So 1/2 squared is 1/4. Let's pull it out. So put it with the pi over 8. Okay, and then we had x cubed minus 3x plus 2 dx. Okay, sorry, I miswrote that one. Sorry. That's the area of each semicircle. So wherever you're at on the x-axis, the area of that semicircle in that place is going to be this formula right here. Now, because we're going to end up integrating in just a second, it turns out we're going to need to split this up. So let's go ahead and split it up. Pi over 8. Okay, let's go ahead and multiply. So x to the 6th minus 3x to the 4th plus 2x to the 3rd. Let's see here. Here plus, minus 3x to the 4th plus 9x squared minus 6x, and then we've got plus 2x to the 3rd minus 6x plus 4. Okay? And then of course you could combine, so that should be a 4 right there, sorry. Alright, so we've got pi over 8 times, we've got x to the 6th. Let's see here, negative, so minus 6x to the 4th. Let's see here, plus 4x to the 3rd. So plus 9x squared minus 12x plus 4. Now, what we're going to do is we're going to integrate from -2 to 1. We're going to have that whole thing there. Okay, x to the 6th minus 6x to the 4th plus 4x to the 3rd plus 9x squared minus 12x plus 4 dx. Great. And then and so then you basically you can go ahead and do that by hand, or you can plug it in your calculator. Either way, you're going to get the volume of the whole shape. Okay. Now, here's the thing though. That's one part. That's how you find the actual volume. Okay. Now, what we're going to do though is we're going to say that there might be an approximate volume. Okay. So what we're saying is, imagine that you were to take -2 to 1, and imagine you cut it up into a bunch of sections. Okay. So -2 to 1. Okay. So the whole way, let's say that you've got from -2 to -1 to 0 to 1. Now let's say you had, 10, 10, and 10, okay? So let's say that you went and created a whole list of x numbers from -2, -1.9, -1.8, -1.7, and so on, all the way to -1, then -0.9, -0.8, and so on and so forth. 0, 1, sorry, 0.1, 0.2, on up until 1. Now if you do this way, you're going to have 31 x locations. 31 x's. Now what that means is that at each one of these we would pretend that there was a semicircle there with a certain width. Now let's say that at -2, imagine that I had a semicircle at -2. Okay, this is kind of sideways. Let's show. So if I had it at -2, so then what I would do is I would say, okay, that area is going to be what we had found earlier, the whole x to the 6th, all that, blah, blah, blah. So that area would be pi over 8, x to the 3rd minus 3x plus 2 squared. Okay, so that's the area of that semicircle. However, we're creating volume. So notice I put 0.1 in between each of my measurements. So let's say that I took that whole area, okay, and multiplied it by my width, by my delta x, which is 0.1. So what I'm saying is that I am approximating the volume of a single semicircle at that one point. So I'm finding that approximation. Okay. Now I then keep going, and what I do is I plug in -2 to my first one. Okay. So what I'm going to do is I'm going to make a whole spreadsheet. Okay. I'm going to put all my numbers in there: -1, -2, -1.9, -1, all the way down. Okay, all the way down to 1. Now what I'm going to do is I'm then going to plug in the area for each one, and the area is going to be this whole thing that I just found, and plug it in for each of those. Then each one is going to be multiplied by 0.1 because that's how thick my slices are. So I'm going to find the volume of each one. Okay, and each one is going to be there, and then I'm going to add them up, and when I add them up, that's going to give me my approximate volume. So when I'm building my actual 3D shape, okay, what I'm building is actually based on all of this. Okay, so I'm building the approximate volume. Now, what I'm going to do with that approximate volume is I'm going to show that it is very similar to the actual volume. Now, by the way, you may have remembered right hand, left hand, all that stuff. So just keep in mind that it won't matter if you use both the -2 and the 1, because both of those will end up being a 0 area. So yes, according to right and left hand approximations, you should use only one or the other. But in our case, they're both going to be 0, and so it really won't matter at that point. Okay. Now, so what you're going to do for your project, you're going to actually create the physical 3D structure with cross sections. You're then going to give me the actual volume, and then with a spreadsheet and your areas, you're going to give me the approximate volume, and you're going to show how they're both equal. Okay. Now, don't forget, I need to see all of your calculations. You don't have to actually show me the final, like integrating it part of it. That's not what I care about. But what I do care about is all the process and what your actual volume is. And then I want you to show me the spreadsheet in which you give me the approximate volume. I want to see all of that. So that's going to be your project. Now, by the way, just some reminders. For those of you who have squares, don't forget that the area is the base squared. For those of you who have semicircles, your base is going to be, your area will be pi over 8 times the base squared. Okay. Now for your equilateral triangle, that one should end up being square root of 3 over 4 b squared. Okay. And the isosceles right triangle, that one should end up, you should end up with 1/4 b squared. Okay. That's because of the way that we have it angled. We're going to angle it like this, not like this. Okay? All right. Yeah, so you should be able to, you've got your base. Yeah, that's about half of that. And yeah, so it should be about 1/4. Okay? All right. If you were to change it the other direction, it would change the volume. All right, hope that helps, and we'll go from there.